there's one mini break in between the show segments where we'd like you to fill out the first section of the survey questions. If you have not gotten a survey and you're interested in filling it out, I can tell you more about it, and I've got some extra copies. Also, the pens you can keep, we got them as a donation. If you're interested in helping us, we have more surveys that we can hand out. Otherwise, thank you for coming, and I hope you have a good time.
Imagine we sent out a probe to explore the planets in our solar system. You might have heard about NASA's mission, New Horizons, to one of our dwarf planets, Pluto. The spacecraft have a lot of different sensors, but imagining the camera, the one that sends us visual information, broke. How could you compare the information we have using sound? What if you can't send back pictures like this one of Pluto and its moon Charon? Even with these wondrous images to let us see the other planets, how can we actually experience them? How can we explore our closest neighbors? How long is a day for them, or their year? How large are they compared to Earth? What's the weather like? We're going to go on a journey through our solar system, not using our eyes or pictures that you might be familiar with, but using sound to help give a sense about the other planets around us. Let's start at the sun and hear all the planets move around.
Venus is the second planet from the Sun. It is generally our closest neighbor. Sometimes Mars is close. It's often referred to as Earth's evil twin, since its atmosphere is mostly carbon dioxide and it rains sulfuric acid instead of water. Its thick atmosphere makes it the hottest planet in our solar system, even though it's not as close to the Sun as Mercury is. All of these factors, including its high atmospheric pressure, mean that every probe sent there has been destroyed by Venus's hostile environment.
Earth, our home. We're the third planet from the Sun, and the largest of the terrestrial planets. We're also the densest planet in our solar system. With an active core, an atmosphere, and water, we are the only planet known to support life. Earth also has one moon, which affects our tides.
Mars. Mars is occasionally our nearest neighbor, and the source of much discussion about life and water on other worlds. It's smaller than Earth and has polar ice caps. It has amazing geological features, like the ancient extinct volcano, Olympus Mons, which is about 3 times the height of Mount Everest. Mars also has 2 moons, Deimos and Phobos.
In between the innermost planets, like Mars, Earth, Venus, and Mercury, and the outer gas giants, there is an asteroid belt. The exact number of asteroids is unknown, though the total mass of the asteroid belt is estimated to be less than our moon. The more notable inhabitants of the belt include Ceres, the dwarf planet, and one of the larger ones, Vesta. Unlike how they're shown in movies, asteroids are quite far apart. Jupiter is the fifth planet of the Sun and the largest planet in our solar system. It is a gas giant. It has over 60 moons and a faint system of rings. Jupiter is known for the Great Red Spot, a huge storm that is larger than Earth. To give you an idea about how large it is, you could fit about 1,300 Earths inside of Jupiter.
We just mentioned it, but here's Saturn, the sixth planet from the Sun. It's another gas giant and is best known for its beautiful system of rings. Saturn has 7 layers of rings, and on these 60 moons. Titan, one of its moons, has an atmosphere and seas made of methane.
Uranus, the seventh planet from the Sun, and one of the 2 ice giants in our solar system. It has a system of rings, which are hard to observe based on the planet's tilt. Uranus rotates on an axis so extreme that it rolls like a barrel. It has 27 moons.
And last but not least, Neptune is the 8th planet from the Sun, and the second ice giant in our neighborhood. It has a thin system of rings and 14 moons. Some of its most interesting features come from numerous atmospheric storms, the most well-known being the Great Dark Spot. And this isn't even the limit to our solar system. There's the outermost dwarf planets, including Pluto, Makemake, Eris, and Haumea, the Kuiper Belt, where icy bodies like comets come from, and maybe even a mysterious planet even further up than those we know of.
Now that we've gone through a quick introduction of the planets, we're going to do what you came here to do. Find out what solar system sonification really means. If we just wanted to compare the planets based on size, and here that means mass, something like this might be confusing. But let's break that down. Because we're using sound, smaller planets have a higher pitch, and larger planets have a lower pitch. This is kind of like hearing a mouse walk versus hearing an elephant. In order to make it easier to understand, let's start with Earth.
Rather than using a linear scale, we use a logarithmic scale to fit the wide ranges of planetary masses into the range of human hearing. Overall, Mercury, Venus, and Mars are smaller than Earth, though Venus is close in size. This is Mercury. Notice how the sound is a much higher pitch than Earth's. Now compared to Venus, it's much more like Earth. And let's get the last of the terrestrial planets, Mars. Its pitch is higher than Earth's because it's also smaller. Now here comes the fun part. The outer planets, those guys outside the asteroid belt. Jupiter is the first planet we'll encounter, and it is massive. Remember, it's the largest one in our solar system. It's much larger than Earth. Here is Earth and Jupiter together. And it's even larger than the next closest in its size, Saturn. Here's Saturn and Jupiter together. At this point, we've made it to the 2 ice giants, Uranus and Neptune. While these are still larger than Earth, they're much smaller than Saturn. Now let's hear them separately. Which one of them is larger? It might be hard to tell, but it's Neptune. If we play all of the sounds showing the sizes of the planets now, it's easier to separate it.
Thinking about the size of planets is cool, but still might be hard to completely grasp. Let's go to something that's a little bit more relatable to us. How long is a day on Earth? About 24 hours. Here we map the length of day to the tempo. So the faster you hear the beats for each planet, the shorter the length of day. If it has a very long day, you should notice a much longer amount of time in between the beats. Here, the frequency of each planet is the same as the one from before, based on size, and the tempo will change, giving us information about the length of day. Again, let's start with Earth. One of the interesting things about the two innermost planets is how long the days are for Mercury and Venus. Here's Mercury. And here's Venus. Mercury and Venus don't appear to be because their days are so long. A day on Mercury lasts 176 Earth days. A day on Venus lasts 116. Mars also has a similar length of day compared to Earth. So let's hear Earth again to compare. And now let's play Mars. They should sound very similar since Mars takes 25 hours to complete one day. The Jovians, another name for the gas giants, spin more quickly than Earth, and so they all have shorter days. Jupiter and Saturn are the fastest, and complete their days in about 10 hours. Here's Jupiter. Here's Saturn. Compared to them, even Uranus and Neptune are a bit slower. Here's Uranus. Here's Neptune. Now let's compare all the 4 terrestrial planets with each other. Mercury, Venus, Earth, and Mars. And now let's hear all of the 4 gas planets. Jupiter, Saturn, Uranus, Neptune. Here's all of them together. Length of year is also something I'm sure you're familiar with. A year is defined as how long it takes a planet to rotate around our sun. We've mapped the amount of time it takes for each revolution to how long it takes the sound to move around you in the planetarium. Of course, we've sped up that duration, since no one wants to wait 165 years for Neptune to circle. Earth takes approximately 365 days to complete one revolution around the sun. Mercury and Venus are both closer to the sun, so their path around it is much smaller. Mercury is the fastest, since it is the closest.
Venus is still faster than Earth. Finally, for the last of the terrestrial planets, let's hear Mars. It takes about twice as long as Earth to orbit the Sun. Let's hear the first 4 planets so we can get a feel for how fast they move compared to each other. Now, since the outer planets take so much longer than the inner ones, in order to make listening to them easier, we'll instead use Jupiter as the reference point. To give an example, a year on Jupiter is 12 times as long as one on Earth. Now let's listen to Saturn, Uranus, and Neptune in order compared to Jupiter. Notice how they're all moving around us in the same direction? That's due to the angular momentum from when the solar system first formed. Another way to think about it.
Yeah, hi guys. So one of the things we'd like you to do right now is, if you have this survey, to answer the first section and just sort of reflect on if there's how you felt about it. Thank you. So I think that we're going to continue on with the rest of it. We won't ask you to fill out anything else in the survey for the rest of the show, so feel free to leave the rest of it till the end and just relax and enjoy. Thank you.
Another way to think about this would be to think about the distance from the Sun to each planet. To do this, we'll again start at the Sun and move to each of the planets. Listen for the fading in and out, or the silence, as it takes longer and longer to approach each of them. When each planet is reached, the name of the planet is said.
We've arrived at Mercury. Let's head to Venus. Now we've reached Venus. Next stop, Earth. We're at Earth. Next Next stop, Mars. We've reached Mars. Jupiter is much farther away, so we'll need to throw in our boosters and go 5 times as fast. Now we're at Jupiter. Let's continue on to Saturn. To reach Uranus, we'll have to go twice as fast. Throw on that hyperdrive. We've reached Uranus. Next stop, Neptune. Now we're at Neptune, the last planet in our solar system. Here, we'll be exploring what it would be like to be on each planet, hearing features like moons, rings, weather, atmosphere, temperature, and gravity. What would it be like to stand on Mercury? Well, there isn't much atmosphere, so you wouldn't hear wind or anything else if you were on the surface. And, depending on which side you stand on, either the one facing the sun or facing away, it would be either very cold or extremely hot. Mercury is a terrestrial planet, so you would be able to feel the ground crunch and shift under your feet. So what would that sound like? Gravity is also very different on Mercury. Mercury has about 1/3 as much gravity as Earth. If you were to bounce a ball on Earth, here's what it would sound like. Now let's hear what that would sound like on Mercury. As we mentioned earlier, Venus has a very thick atmosphere filled with gas like carbon dioxide. Earth, a planet we all know. This is the first planet we encountered in this section to have a moon. It has complex weather patterns and is also a terrestrial planet. You might already know what it sounds like to bounce a ball on Earth, but let's hear it again. Our gravity is a little stronger than Venus's, which you might be able to hear. Here's Venus. We also have complex weather systems and an abundance of water on our planet. How do all of these factors, as well as the more moderate temperatures, affect what Earth sounds like? Mars is the last of the terrestrial planets. It has 2 moons, though their orbits are unstable, and one will eventually crash into Mars, while the other will leave the orbit completely. Mars has a small mass and about the same amount of gravity as Mercury. This means that the ball bouncing simulation will sound almost exactly the same for Mars as it did for Mercury. Mars is much colder than Earth and has a thin atmosphere mostly made up of carbon dioxide, the gas we exhale when breathing. So how does Mars sound different than Earth?
the gas giants. Its gravity is over twice as much as Earth's. If you could stand on the surface and you weighed 100 pounds on Earth, you'd weigh about 250 pounds on Jupiter. This massive planet has a system of thin rings and an estimated 67 moons, the most of any planet in our system. Jupiter is famous for its magnificent storms, including the Great Red Spot. It is made up almost entirely of gas and has amazing lightning storms that have been recorded through numerous missions. Let's hear how Jupiter sounds different from any of the rock planets we've heard so far.
Saturn, the next largest planet and the second gas giant, is known for its beautiful, complex system of rings. Saturn has the most moons after Jupiter, many of which are embedded throughout the system of rings. Gravity on Saturn is a little stronger than Earth's. Saturn is mostly made up of hydrogen and helium. It's quite cold compared to Earth, and it has the second fastest winds in the solar system, with the only ones being faster found on Neptune.
Uranus follows the other gas planets, in that it has a set of rings and moons held in its orbit. It radiates very little heat compared to the other gas planets, and is the coldest planet in the solar system. Its blue-green color comes from the methane in its atmosphere. So how do the ice giants sound compared to the gas giants?
We've arrived at the last of the planets. Slightly larger than the outer ice giant, Neptune's gravity is more than Earth's, and actually fairly close to Saturn's. We'll listen to Earth, then Saturn's, then Neptune's, to give a comparison. Neptune is another icy cold planet in the outer solar system, and appears blue for the same reason as Uranus. Neptune's rings are very faint, like Jupiter's, and Neptune has over a dozen moons. It's known for its large storms, such as the Great Dark Spot in its atmosphere, and has the fastest moving winds in the solar system. How does Neptune sound compared to Uranus, its neighboring planet, frequently called the most bland of the gas giants? Here's Uranus. And here's Neptune. Let's listen to the range of temperatures on all of the planets in a row. Mercury. Venus. Earth. Mars. Jupiter. Saturn. Uranus. And Neptune. This has been an auditory journey through our solar system. We would like to thank Captain Brianna Tomlinson, Lieutenant Bruce Walker and the Sonification Lab, and Colonels Smruthi, Bhat and Milap, Rane. Your flight attendants this evening have been Chris Latina and myself, Mike Winters. We are going to close this program with a cosmic remix by DJ Brandon Westergaard entitled The Next Brain.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.